Before we solve a couple linear equations, let's just review the basic steps. Okay, so first of all, we want to simplify on both sides. We want to make sure that we have at most one number term and one constant on each side. This may require distributing to get rid of parentheses. It may require multiplying everything in the equation through by something to get rid of fractions. Once we've accomplished that step, then we want to say, well, let's move all the numbers to one side and all the variable terms to the other side. So the second step is usually accomplished by adding and subtracting from one side to the other to undo where those terms are, to move them. The next step is to isolate our variable. So if it's 2x, I want it to be just x. That 2x indicates multiplication, so we usually do this third step here by division. The final step is important, especially when you're taking a high stakes assessment, so make sure you check your answer in the original equation before you did anything and make sure it really works. Now let's try a couple examples. Okay, first one here, 2x plus 5 equals 6x minus 7. One number, one variable on both sides, so no simplifying needed. Now I want to get all the x terms on one side and all the number terms on the opposite side. As I said, there's no rule where x has to go. My personal feeling is I don't like to work with negative x terms, so I'm going to try to keep my x's positive. When I'm looking here, on the left side I have a 2x, on the right side it's a 6x. So I have to subtract because they're both positive. Either way I move, if I subtract 2x from 6, that'll leave me something positive. So I want to move it to where I have the higher number of x's. Now at the same time I'm moving the x's, I could go ahead and move my constant terms. So all of our x's are going to end up on the right side. That means I need to get rid of the constant on the right side. You notice it's a -7. So to undo that, I need to add 7. So instead of minusing 7, I'm going to add 7. What I do to one side, I do to the other. Now we're going to go ahead and work vertically. So the x terms on the left canceled. 5 and 7 makes 12. Keep track of where your equal sign is. 6 minus the 2 is going to leave me with 4x. And again, the constant terms on the right canceled. Now we're down to the step of isolating the x. So I see 4x indicating 4 times x. So I get rid of the 4 by undoing that and dividing both sides. And then I get an answer here, 3 equals x. Well, there's a reflexive property of equality. So instead of 3 equals x, I could rewrite that the way we're more used to seeing it as x equals 3. Okay, now I mentioned the check. So how would we do that if we wanted to check this? We would take that 3 and put it back in the original equation. So 2 times 3 plus 5 equals 6 times 3 minus 7. All right, now you notice I put a question mark because I'm checking. So simplifying on the left, we get 6 plus 5, which would be 11. And then again, we're checking. On the right-hand side, that would be 18 minus 7. Okay, so 18 minus 7 is 11. 11 equals 11. We've got the correct answer. Let's take a look at the other one. This one is going to require a little bit of simplifying. I have 3 times the quantity of 5 minus x equal to 4 times the quantity of 2x plus 1. We know that when you have a number right in front of a parenthesis, that means we distribute, multiply to everything inside the parenthesis. So we're going to do that on both sides. On the left, we'll get 15 minus 3x. On the right, we're going to get 8x plus 4. All right, now pause it here for a moment and see if you can finish this problem. Okay, hopefully you paused, and let's see if we came up with the same answer. So for this one, I'm looking here, I've got a minus 3x on the left, a positive 8 on the right. There are more on the right again, so I'm going to go ahead and say let's add a 3x. Why am I adding? Because it's a minus 3x. The add 3x makes it cancel, so everything goes to the right-hand side. Well, if I'm going to move all the x's to the right-hand side, that means I need to get rid of the 4 on the right-hand side. It's a plus 4. So I undo that by subtracting, and then I do the same thing on the left side. Working vertically, I come down to 11 equals, because the x terms canceled, 11x, and then the 4's cancel. All right, final step here is to isolate that x. We're going to go ahead, not divide by x. That's what we want to keep, isn't it? We want to instead divide by the 11 on both sides and get my final answer here. I guess I switched to green. 1 equals x. Right? A number divided by itself is 1. It doesn't just cancel and go away. It's 11 divided by 11 is 1, or again, if you prefer, x equals 1 would be our solution.